All right, this is linear inequality and the number line, L2. And what they want you to do is they want you to solve the inequality and graph the solution on the line provided. So I got a couple different examples here for you. Let's do the blue in here. So basically the idea here is we're just solving as if this was an equal sign. And sometimes I will literally just think to myself like, all right, like just pretend this is an equal sign and solve it. But you got to be careful because there are some rules here with the inequality sign. So let's do it. So if you've got negative 4x plus 54 is greater than or equal to 70, your goal here is to get this x all by itself. And what we're going to do is we're going to have to get rid of the 54. We're going to have to get rid of the negative 4 here. So for me personally, I like to minus 54 first. Remember, whatever's being done over here, you want to do the opposite. So it's plus 54, so we're going to subtract 54. So we got negative 4x is greater than or equal to 16. And then from here, what we're going to do is we have to divide by negative 4. Now, this is the most commonly forgotten rule, I think, probably, in Algebra 2. There might be one or two other ones that are more commonly forgotten, but this one gets people really bad. When we divide by negative 4, it cancels here, so we're left with x here on this side. And then 16 divided by negative 4 is negative 4. But what you have to remember is if you multiply or divide by a negative number, you have to switch the way this sign points. So it's going to become x is less than or equal to negative 4. So the rule is if the number that you are dividing by or multiplying by is negative, you have to flip it. We don't care about the 16. Like even if the 16 was negative here, that wouldn't matter. It matters that we divided by a negative number. Okay, so if you multiply or divide by a negative number, switch the way the sign's pointing. Okay, so we have x is less than or equal to negative 4. So what's going to happen there is on that number line, you're going to here's 0, here's negative 4. You're going to put a point here, and then you're going to go x is less than or equal to negative 4. That means you're going to shade, less than means left on the number line. So that means we're going to shade everything left on the number line. So you'd want to drag that all the way until it's to the arrow. Don't drag it from like here to here. Like some people were getting that question wrong yesterday. Make sure it goes all the way. A couple other things. If this is less than or equal to, this needs to be a solid dot. Okay, so fill that in solid, less than or equal to. If it was just less than, then what would happen is you'd have an open dot here, okay? So if it's just less than, you'd have an open dot. But since it's less than or equal to, we shade that in, okay? All right, let's do another one. How about 3x minus 7 is greater than negative 19? So we're going to add 7 to both sides. And we've got 3x is greater than, let's see, negative 19 plus 7 was negative 12. And then we're going to divide by 3 on both sides. And we got x is greater than negative 4. Notice how I'm not flipping the sign here. I'm leaving it the same. Why is that? Because I divided by positive 3. Okay? It's negative 12 over here, but I don't care about what's over here. I care about what I'm dividing by. So in this case, I'm dividing by a positive number, so I don't need to worry about flipping the sign at all. Okay, so x is greater than negative 4. So what we got here is we got a number line. Here's 0. Here's negative 4. Okay, so this one is saying x is greater than negative 4. So we're going to do an open dot because it's greater than. If it was greater than or equal to, we would shade this in. And then greater than just means further right on the number line. So that means we're going to draw everything to the right of negative 4 there. Okay, so that's a nice little refresher on how to do inequalities.